Hello, Matt G for IYT here. Today we're looking at the full license mock examination number 1, version 1.6, and we've reached question 36, which reads: the critical frequency and maximum usable frequency for local and long distance DX contacts depend on ionospheric conditions. Which of the lists correctly shows the various frequencies in ascending numerical order? So we've been given a list of labels, or some labels that can be applied to frequencies, and we need to figure out which of these goes in increasing frequency order. And hopefully we'll all remember that radio waves can be bent or refracted as they travel through our ionosphere, and sort of for HF frequencies, certainly a radio wave's path will be bent or refracted as it travels through the ionosphere, and that can allow it to be sent back down to Earth. Or it may be so high that it is only refracted a little bit and then it sort of disappears off into space. And as a general rule of thumb, lower frequencies get refracted more and higher frequencies are refracted less. However, there isn't a hard and fast rule for how much a signal at 7 megahertz will be refracted, because it depends on the level of ionization within the atmosphere and the prevailing ionospheric conditions, which of course are constantly changing. So rather than saying, well, 40 meter band is always refracted this much, we instead can use these labels to describe frequencies that give us certain properties. So first of all, we have CF this is for critical frequency, or the critical frequency of vertical incidence. And really what this means is, what is the maximum frequency that if we were to fire it straight up at the sky would be refracted so much that it returns back down to Earth, maybe even sharper than that, fire it straight up and it comes right back down to Earth again. And so it's the critical frequency of vertical incidence. We send it up vertically and it comes back to us. So this is the frequency of signals that are refracted so much that they come right back down again. And then we've also got the maximum usable frequency for local contacts or DX contacts. Of course, we know that the amount that a signal will be refracted depends on the conditions and its frequency. So we may see that some signals are refracted so much that they come back down, they're refracted back to nearer stations, whereas some are refracted much less and they come back down to more remote or DX stations. So it stands to reason, because we know that higher frequencies are refracted less, that our maximum usable frequency for DX contacts is probably going to be, at any given time, is going to be the highest frequency of this set of labels. So we've got our MUFDX, which I'm drawing underneath myself there, so that's probably not particularly helpful. And we know that the critical frequency is the highest frequency that's immediately returned, but it's the one that's got the highest levels of refraction, so that's going to be at the lowest end of our scale, and that leaves the MUF for local contacts is going to be slap bang in the middle. So let's go and take a look at our answers. And so we're looking for the critical frequency first, which we've got here. We're then looking for the maximum usable frequency for DX contacts last, with the maximum usable frequency for local contacts in the middle. And these questions are always a bit tricky, because this isn't answer A, this is actually answer B. This is B here. So I believe that it's going to be critical frequency is going to be the lowest one, the maximum usable frequency for DX is going to be the highest one, and that leaves us with answer B. Let's go and check the answer, see if we've got that right. And yes, of course, for question 36 we see the answer is B. Thank you very much for putting up with my poorly drawn pictures, and I'll catch you for the next one.